Welcome to Ionic Equilibrium class. In this session, we will go with Bronsted Lowry theory. In the last one, we were discussing about Arrhenius theory. This you can say part 2. Concept of acids and bases. Very relaxedly we'll learn. Okay now. So Arrhenius theory says that H plus if it is donating acid, OH minus if it is donating base in water. Here, this theory is called protonic theory. Here the acid means proton donor. So this is same. And base means proton acceptor. Here the difference. If acid is given out, that is, proton is given out, that is acid. If proton is accepted, that is base. Very, very simple line. Now, for example, ammonia is there. And you are taking water. Now, ammonia is taking proton from water, becoming NH4 plus, and this becomes OH minus. So here ammonia is accepting proton, so ammonia is base, right? It is donating proton, so this is acid. After gaining the proton, it became ammonium, so this is called conjugate acid. After losing proton, it became OH minus, so this is called conjugate base. So in simple sense, you can say, for example, you have H3PO4. If it is acid, good, H2PO4 minus, it is conjugate base. One proton difference. There should be one proton difference, then they are called conjugate acids and bases. Okay, one more example we'll take. H2O plus HCl I am taking, becoming H3O plus and Cl minus. H2O is here accepting proton from this. So this is base. It is providing, so acid. H3O plus is called conjugate acid. Gained proton, so conjugate acid. It has lost, so conjugate base. Very, very important line. You just see. If any compound is given, you just need to be very careful in this. H3O plus, take out one proton. H2O, take out one proton. OH minus, take out one proton. O minus 2. If this is acid, it is conjugate base. If you are saying this is acid, yes, it is conjugate base. If you are saying this is acid, it is conjugate base. Okay, now only these two you can see. Only these two you can see. Only these two. Don't compare the first and last. Okay, now H3O plus conjugate base is O minus 2, don't see. Okay, now only one proton difference should be there. Only one proton difference. See, I will show you one more. NH4 plus. Okay, now we will go with some thick colors. Thick means it came light. Again light. Light is better, right? NH3, NH2 minus, NH minus 2 and N minus 3. See, if it is acid, it is conjugate base. Now if you are saying this is acid, it is its conjugate base. Then this is acid, it is its conjugate base. If this is acid, it is its conjugate base. Okay, and any two, this combination you can say conjugate acid base pair. This combination conjugate acid base pair, conjugate acid base pair, conjugate acid base pair. So what we are saying, one proton difference, conjugate acid base pair, conjugate acid base pair. What we need to remember here is, for example, HCl, it is strong acid. When HCl is strong acid, Cl minus, its conjugate base, is weak. If acid is strong, its conjugate base is weak. If base is strong, its conjugate acid is weak. If acid is weak, it is weak acid. Organic acids are weak acids in general. So CH3COO minus, if you are taking, this is strong base. So if acid is strong, conjugate base will be weak. And vice versa. You can apply the same for the bases also. Okay, any base you take, ammonia, if it is weak base, NH4 plus is strong acid, like that. If acid or base, if they are strong, their conjugate will be weak. If acid or base they are weak, their conjugate will be strong. Why like that? That is the point. Okay, these kind of questions you should ask. See, HCl readily releasing H plus and Cl minus. We are saying this is strong acid. We are saying strong acid means it is easily providing protons. That means this is stable. Okay, when this is stable, it can release the protons very easily. Okay, and it is not accepting protons back. Correct? So in that sense, you try to remember, the things will be easy. Bronsted Lowry concept. So transfer of proton, you can say here, transfer of proton is neutralization. One more line you can be asked here, that is leveling effect of water. For example, if you are taking HNO3, H2SO4, HCl, all these acids you are taking in water. If you are taking in water, all their strengths are equal. All the acids, their strengths are equal. All the bases, NaOH equal to KOH equal to barium hydroxide in water. All the acid strength will be equal to the H plus ions of water. All the base strength will be equal to the OH minus ions of water. This is known as leveling effect of water. Leveling effect of water. When leveling effect of water is known to you, you should not decide the strength of the acids or strength of water in strength of bases in water. Strength of acids or bases not in water. You should not say in water. If you are saying in water, gone. Okay, because all there will be equal. This is known as leveling effect of water. All the acid strength will be equal to H plus ions of water. All the base strength will be equal to OH minus ions of water. So in this sense, you cannot judge which is stronger acid. So to decide that, we will discuss in next session. Thank you.